This is explainable AI and deep transfer learning for maize diagnosis. Um, the contents of the presentation are as follows: from the introduction to the acknowledgement. Um, why specifically maize? Because maize is the staple food for millions of people around the world, and especially to take an example, East African region, it is used. The production was around 17.2 million tons in 2016, and why are we supposed? What's the problem here? So, in case because of the problem of diseases in the because of the problem of diseases in maize, it has led to low production and which has seen if you see here down there's a child who is down showing the implication that it may also lead to hunger. So uh, traditionally what has been used it is normally uh, observation mostly by agricultural experts and those people and other farmers who have had some experience with maize disease, but this has proven to be inaccurate because sometimes someone may not observe properly, or he may misdiagnose a certain maize disease, and which can cause problems, or someone can classify a healthy one, health, eh, someone can classify a disease to be healthy, which leads into problems. So we are introducing deep learning for the for the for the for the case of diagnosing these many diseases. So, uh, the goal of this, the main goal, the ultimate goal of the project is to produce a practical and effective solution for diagnosis of diseases using machine learning, uh, using explainable AI. So, in explainable AI, we shall develop our model, and we shall use some techniques to explain how the model has come up with, with classifying a disease, which can help to give these people, the farmers and coach experts, more confidence into the model.
Now, wait. Now, on the part of problem statement, the research problem here is to develop a diagnosis system that can accurately diagnose maize streak and leaf blight disease based on the image of the infected plant. And as we have seen in our previous slides in the introduction, there is really a big challenge of the current systems that farmers are using to diagnose these diseases. And also here we shall provide a clear and understandable explanation of how the system came up to its prediction. And as we have seen in the previous slides, there is a lack of one effective and easy to use diagnosis system for the maize streak and leaf blight diseases. And especially for our local farmers, the current system is not suited for them since it can be expensive. So the current system cannot be used in the resource limited settings and may be unreliable and costly because you cannot at times trust human judgment. So therefore the problem statement for this study is to address the challenge of accurately diagnosing maize streak and leaf blight in resource limited settings. And here we shall be using explainable AI and deep transfer learning techniques to develop a diagnosis system that can accurately diagnose these diseases and also explain how it came up to the predictions, and it should also should be easily usable to these farmers. And these are some of the research works that has been carried out. For example, there was an advanced microscopy technique that was designed for detecting tussium in maize. Chen and Wang developed a method for identifying maize leaf diseases. For them, they use PNN and image processing with SVM, and also an adaptive weighted multi-classifier was designed, and it had like 94.7% accuracy or average recognition rate, and many others. But most of these systems that were designed, they had limitations. They could not be used for large sample sizes. And for example, when we look at the advanced microscopy, it required some complex equipment and couldn't be taken into the field. And some others, for example, the SVMs and the YOLO, they were not compared to other systems or models to see how their performance measures compared to others. And also there is a lack of study that focuses on explainability and real-time guidance of specifically these two diseases. So therefore, there is a research gap in the literature review for the study that develops and compares a range of image classification techniques, including both the traditional and deep learning approaches for identifying the maize diseases. Now, this brings us to some of our research questions. For example, here we shall be looking at how traditional models perform compared to transfer learning models. For example, we need to know the effectiveness of the deep transfer learning for image classification. We need to know the performance of a model trained from scratch performs compared to that of that pre-trained. We need to know explainable AI can be used to provide a clear and understandable explanation for the diagnosis of these diseases. And also we need to know how the mobile application and an external database can improve the usability and accessibility of this diagnosis system. And we would also want to know the impact of the diagnosis system on the cultivation and management of these diseases. Now, this brings us to the objective. Now, the main objective for this project is to design an intelligent system that can identify and classify these diseases, the maize streak and leaf blight, and also explain how it came up with predictions. And it will be able to provide real-time guidance to farmers on how to manage these diseases and optimize maize cultivation. And the specific objectives for this study is to design an image classification model from scratch that can recognize the presence of maize streak and leaf blight, and also to utilize transfer learning. Now here we shall be using VGG19 and ResNet50 as our baseline models, and also we shall compare the accuracies of these models using evaluation matrices, which we shall see later on in our methodology. And also we shall use explainable AI techniques like the feature importance analysis and the salience maps to provide a clear and understandable way of how these models came up to their predictions. And also we shall deploy the model on a mobile application. Okay, let me let my other colleague continue.
For the methodology part, this is our structure. So after collecting our data, we shall perform some exploratory data analysis, whereby we shall use graphics and visualizations to explore and analyze our data. Then perform some data pre-processing. In this stage, we shall perform some data cleaning, image standardization, image transformation, cropping, scaling, and other activities. We shall design our model, whereby we shall basically use a deep learning model. In our case, we shall use a convolutional neural network. Then we shall also utilize some transfer learning and use some pre-trained models, whereby we shall use VGG19, ResNet50. Then, after designing our model, we shall perform model evaluation, and we shall utilize evaluation matrices, for example, the use of accuracy, precision, recall, F1 score, AUC. Then from these three models, we shall select the best performing model, then perform some explanations on our model. In this case, we shall use LIME, SHAP, LRP, Salicy maps, and many other explanation techniques. Then we shall deploy our model now in a mobile application using TensorFlow software tool. Then allow users and farmers. This deployed model will allow users and farmers to easily diagnose these maize plant diseases based on the images captured using their mobile phones. Then we shall create and these are expected results. previously. These are expected results, whereby we shall classify our accuracy based on these evaluation matrix, which are accuracy, F1 score, the use of precision, recall. Expect our accuracy to be very high. Expect our F1 score to be high. Expect minimum losses. Expect our precision to be very high. And finally, our recall to be high. Based on explanations, we shall basically use SHAP, whereby SHAP uses Shapley values based on game theory to calculate the importance of each feature upon contributing to a certain prediction. These are our features, and these are some of the calculations. This is our explanation framework, which is a combination of both classification and explanations regarding our predictions, whereby our system will be able to take an input from the task and make a recommendation, decision, or an action. So our system will also provide explanations to the user to justify its recommendations, decision, and actions. Let me let my colleague to continue from there.
We expect the developed intelligent system to be able to accurately diagnose maize, streak, and leaf blight disease, owing to the fact that we shall carry out some data pre-processing to remove the irrelevant images and also perform some data analysis to select the most important features that will contribute to the building of the model. Then we shall use the use of explainable AI techniques to allow us to have a clear understanding of the model's decision-making process and provide insights for farmers. We shall use techniques such as LIME, SHAP. Then it is anticipated that development of the explained model on a mobile application will increase accessibility and usability for users, owing to the fact that most farmers possess mobile phones. Then, however, it is important to note that the process study is subject to certain limitations. The performance of the model may be affected by the variations in the quality and resolution of the images used for training and testing. Then, the effectiveness of the model may be limited by the availability and diversity of the dataset and may not generalize well to other crop diseases or species. Further research may be necessary to address these limitations and improve the robustness of the system. For our future research directions, we shall be able to extend the scope of the study to include other types of diseases that affect maize plants, such as rust or fusarium wilt, allowing the model to be widely applicable and useful to farmers. Then we shall explore the use of other image classification models or architectures, such as the CNNs or the autoencoders, to see if they outperform the current model we shall develop. Then we're also planning of incorporating additional data sources such as weather data or crop management practices to see if they have an impact on the model's performance. This weather data will be generated owing to the fact that we shall be able to track the location of where that image, where the data has been recorded. Then we shall evaluate evaluate the model's performance on different types of maize plants, such as sweet corn or popcorn, to see if it generalizes well to other varieties. Then investigate the potential for using the model to predict other crop diseases. Then for the recommended future works, we are planning to collaborate with agricultural experts or practitioners to better understand the needs and challenges faced by the farmers when it comes to diagnosing and managing disease in maize plants. Consider developing a more user-friendly interface for the model, such as a mobile app, to increase usability. Then also conduct field tests to assess the effectiveness of the model. Then finally, explore the potential for integrating the model with existing farming management systems or platforms to enhance its performance. Then for acknowledgement, we'd like to acknowledge, first and foremost, we'd like to express our sincere gratitude to Dr. Joyce Nabende. She's the head of the AI Lab for granting us permission to access the AI Lab and for her support and guidance through this proposal process. Then we'll also like to extend our heartfelt thanks to the AI Lab for their invaluable assistance in helping explore areas of machine learning and also like giving us access to their data sets, we shall use for training of our models. Then